So, hello and welcome to our today's live webinar with the topic 19 gaps of DO-178C and how to close them. This is a joint webinar from Vector and Effusion. I would like to introduce ourselves. Our guest speaker in today's webinar is Vance Heidemann. He is CEO of Effusion. The second speaker today is my colleague, Mr. Ingo Niklas. He's Senior Field Application Engineer at Vector, and my name is Winfried Schröder. I'm Business Development Manager at Vector, and I will guide you through this webinar today. Our very short agenda for today looks like this. I will first give you a brief overview about Vector and our solutions. After that, Vance will give us his lecture about 19 gaps of DO-178C and how to close them. And at the end of this webinar, we will answer your questions, which you can always send us via the Q&A window. Here are some facts that give you a good overview about Vector Informatik. Vector has over 7,500 customers in 72 countries and offices in 24 locations in 12 countries. The most of our more than 1,900 employees have been with the company for many years and have gained a lot of industry experience. We also participate in standardization activities and associations by participating in committee meetings and industry meetings. With the VectorCast product family, Vector Informatik is specialized in the testing of embedded C, C++, and Ada applications. VectorCast is designed for the development of safety-critical software in all industries where the evidence for functional safety has to be provided. If we look at the V model, we find the VectorCast solutions at the bottom and on the right side in the rear of system and unit tests. What you can also see here is that VectorCast can be integrated with many tools that you may have already in use. This can be, for example, requirements management tools, ALM tools, modeling tools, or static analysis tools. As you can see, VectorCast integrates with nearly all embedded compilers on the market. They are supported by 100% and they can test the source code exactly as it runs on your target system. It is always valuable to see where you are with your test process and think about where you want to be in the future. VectorCast optimizes the test processes and offers features that help in all areas of software development. It reduces the time for a software test, it allows instant testing after each code change, and maximizes the test frequency. Each developer can check his code changes immediately and is not dependent on the feedback from the QA department. Test drivers and test stubs as well as entire test scenarios are generated automatically. This improves the software quality. VectorCast helps you to move all these bars to the right with features that help in all these areas. So that's it from my side. I will now hand over to Vance and his presentation.
Thank you very much, Winnie and Ingo. It's always a pleasure to work with you. I'm Vance Hilderman, the CEO of Fusion in the USA, and today we have condensed very quickly for you, but thoroughly hopefully, the 19 most common gaps of DO-178C and how to close them. To make your time efficient, we've merged these so you can see that they're concisely presented, and I think we'll get through them just fine. As we look on the next slide, we can see a little bit of Fusion. We work all over the world. We've worked with all 100 of the world's largest 100 aviation companies, and we've done over 120 gap analysis where we've helped over 60 clients close their gaps by understanding how best to proceed with DO-178. We have some interesting quotes. I say that DO-178 is the worst standard in the world except for all the others. Of course, that was Winston Churchill's comment about democracy. But I'm a pilot, not a great pilot, but all pilots know that flight safety really is The number of successful landings equals the number of takeoffs. So let's have a little quiz. See if we can answer these quiz questions that are very important to DO-178C over the next hour. We do plan to have a few minutes of extra time to answer your questions, and Mr. Ingo Nicholas will give us a demonstration of vector in about 45 minutes. First, quiz. DO-178C had huge changes. In fact, it was good for developers. Is that true or false? Next one. Testing is used to improve software and improve high quality. Most bugs come from weak coders, so 178C has strict coding rules. Number 4, 178C is static. It doesn't change, and its interpretation is fixed until the next version, DO-178D, is released. Number 5, DO-178C coupling analysis can be performed by just inspecting the code. Number 6, demonstration and inspection are the preferred verification methods. And the last question, good CMMI rankings, capability maturity model, close the gaps with DO-178C. Let's see how well you did. It's easy, right? True, false. Well, we'll answer these during this webinar. As Woody said, Fusion has done many projects. We've got engineers working in 6 countries, and we've done more gap analysis in DO-178C 254 trainings than all of our competitors combined. It's our core business. It's what we do. Now, key facts. First, the official title, of course, is Software Considerations in Airborne Systems and Equipment Certification. It's considerations, not standards, not requirements. It's a guideline. It was first developed almost 40 years ago, mostly by industry, not government. And remember, industry's main priority is profit, let's be honest, but safe profits, hopefully. We have now 71 objective criteria. The subjective criteria, such as requirements, design, and code, those are specified in your standards. 178 has the objective criteria. That's why they're called objectives. It's not a strict recipe book. It suggests what to do and how to assess compliance, not how to do it. The how comes from you in your standards, but we're going to give you some ideas on how to do that how right now. Part of the avionics development system is 178, but it includes 4754 and 4761 and the new 61A coming out from SAE. Those are the overriding standards that we need to comply with. And something important to know, we are guilty until proven innocent. Let's look at the next slide. Here's the overview. On the left is planning. Planning is small. It's red. It's important. It's on the left, so it comes first. After planning, we're ready to start development. Development is not coding. Development is safety, systems, software, high-level, low-level requirements, the design, then the coding implementation, then integration. In the background, we put it in green. The reason it's green is because that's the color of the U.S. money, right? Here in America, the money is green. So that is a very expensive process. We need to manage that process. It's continuous throughout the project. Now, some key attributes of 178 that we're going to assess for our gaps. We're going to focus on detailed planning, the 5 different criticality levels, consistency, determinism, traceability from top to bottom, meaning are all the requirements implemented as specified, and then for the white box levels, A through C, bottom to top traceability. Does all the code have a reason to be there? That reason is a low-level requirement. Do we have independence? QA, quality assurance, is always independent, but for levels A and B, the engineering activities are largely independent. Be careful if you're level C, you could be tomorrow's level B. Structural coverage analysis, and Ingo will give us a good demonstration on that in another 40 minutes, is required for level A and C and B. Some tools whose output we don't verify need to be qualified. Most tools do not need to be qualified, but of course our verification tools typically do. There's up to 20 artifact types and 71 objectives for level A. And again, since we're guilty until proven innocent, we have to show our receipt. Our receipt, that's our checklist, our transition criteria. Now, let's look at the actual objectives here. Level A, 71 objectives, 30 of them have to be verified independently. Level B, just 2 less objectives. We don't have MCDC nor the source binary correlation, but 18, the verification and QA, are independent. Level C, 62 objectives and only quality assurance is independent. Level D, vastly different. Level D is black box, meaning we don't open the box. We don't see the verified low-level requirements, the design, the standards. We don't even have code for level D. I'm joking. Of course we have code, but we don't open the code. We don't review it. There's only 26 objectives. For level D, it's good, basic, provable software development. And level E has no objectives. We just need one thing, a safety assessment, an FHA to prove we are level E. Now, here's some gaps. If you want a quick video on gap analysis, a 1-minute video, you can go to our website and look at that under gap analysis. But here is a summary. The gap analysis, you look at your processes versus what's necessary. Some of the processes you have are extra. DO-178 has the 71 objectives, so depending on your level, you'll have some overlap. We want to close those gaps. So let's assess the gap between what you're doing and what you should be doing. Leverage the existing artifacts. Never do we have to start over. We can usually keep all your implementation, keep your design, keep your basic tests. Instead, we're going to close those gaps by assessing where you were at. So let's look at the details right here. The most important gap, and there's actually 2 gaps combined here, is not applying 61 and 54A. That's SAE, the Aerospace Recommended Practices at the system and safety level. If you're a military system, maybe you don't formally have to comply. Our European friends are gradually increasing their compliance with 54A and 61. But these are vital parts of the ecosystem, so we really do need to comply with those. Next, we see that we've got a feedback loop, 47, 54, and 61. Here's another gap. Watch this. When we make a change to software or hardware that affects derived requirements, we need to feed those back to the safety assessment. Is there an effect on the safety at the systems development? We have to prove we have a continuous feedback loop. Take a look. We'll see exactly how that works on the following pages. One note, derived requirements are particularly important. Derived requirements are not derived from a parent, but rather from an engineer's, usually a safety or system engineer's, desire to force a certain implementation. But software hardware engineers can also have derived requirements. These derived requirements are derived not necessarily from a parent, but from a desire to incorporate. Since they haven't the pedigree of that parental review, that traceability, they have a particularly problematic potential safety effect. So we have to feed those back to the safety assessment process to ensure we are safe, a very common gap. Now, see those red lines? That's what you have to prove. A very common gap that you don't have those red lines. So make sure you use those red lines, and quality assurance proves that you have that feedback process, those red lines. The next gap, not understanding the optimal route of 178. And this is actually combining several gaps in here. Let's take a look. This is our opinion. This is not FAA or EASA approved. However, They don't disapprove it. Remember, FAA says they don't approve a route. They approve your process to be 178 compliant. So this is our opinion of the optimal route. Look at this. We call this the green snake. It looks like a snake and it's green. It can be expensive, but we can minimize that cost by being optimal. We start in the upper left with the safety assessment. Then quality assurance is fully in place before we do system requirements. Then we develop our 5 plans, our 3 standards, the checklist. We develop traceability from safety to systems and allocate requirements to software. The other requirements will be allocated to hardware like 254. We put everything in configuration management according to plan number 3, which is the configuration management plan. And we have our first SOI, stage of involvement. Then we allocate high-level requirements. We refine, complete them, review them. Low-level, complete review, iterative process. Based on the waterfall, no one uses the waterfall. We use a combination of V-model, spiral, model-based development, and agile. Then we implement code, SOI 2. Then verification, validation, SOI 3. Conformity review, SOI 4. We're ready for flight testing. There's several gaps in here. Many companies, they try to take a shortcut only to find that they took much more time at the end. Also, the full safety assessment system requirements weren't done. There's another gap there. Then we see gaps by merging high-level, low-level requirement decomposition without transition reviews between. That's another gap. So 3 gaps right in there. Now, low-level requirement detail. In 178B, B as in boy, we could have weak requirements. That's not good. When we have weak requirements, we have assumptions. Key goal is to minimize assumptions. That's why we have the objectives and the subjectives. That's your standard. So ask yourself this question. Most companies can't answer successfully. Can 2 different programmers make different assumptions? So we recommend a minimum of 10 to 20 requirements per line of code. So I said that backwards. My apologies. No more than 10 to 20 lines of code per requirement. This negates the needs for assumptions. The average that we see in industry is 40 to 50 lines of code per requirements. That means the developer is making too many assumptions. Write your functional test cases before you make design, and certainly before code. Use this to ask yourself, can I test this? How can I improve the requirement to make it more clear? If you can't test it, then how could you write code for it? Maximize structural coverage by testing those detailed requirements. Use a detailed requirements review checklist, and if you want, you can send us an email and we'll show you a copy of what a proper detailed requirement looks like. You'll have our email at the end of the webinar. Make sure you include details for built-in tests, startup, restart, initialization, exception handling, internal interfaces, I/O. This is another gap. There's several gaps in here also. These are common areas of weak requirements. They're not fun. Nobody likes this part. So it's very weakly specified. Don't do that. You need extra details for that. Now, another gap. These words are wonderful for poetry or love letters, right? Well, they're not good for 178C. These are subjective. Great for poetry, bad for aviation. We should be very exacting, concise, clear, no assumptions in our requirements. So avoid all of these words unless you're writing poetry. Now, the next gap. There's 2 gaps in here. Transition criteria. That small little phrase in 178C with a powerful meaning. Let's consider, what do we really have for a code review? Well, we need the code. Let's just look at the code and see what we have, right? No, I need 6 formal inputs, configured inputs, actual use of the inputs. So the developer is aware of these 6 inputs. The verifier, independent for level A and B, uses all 6 of these inputs, and quality assurance assesses to ensure the verifier and developer did exactly that. What are those 6 inputs? Easy. Source code, checklist, coding standard, the software design, because remember, the design is the bridge between requirements and code. Then the actual software requirements, the requirements trace matrix. These are the 6 inputs. The outputs, completed checklist, using all 6 of those, and notation of action items and defects with a feedback loop to close those defects. That's the transition. Almost always in our 110 gap analysis that we've done, this is a missing criteria. Now, inefficient testing. Testing can be expensive. Testing does not directly improve quality, but rather it's a key, vital aspect to assess quality and then improve quality by providing a feedback loop. Okay? We'd like to see how efficient your testing is, because otherwise DO-178 testing can be like owning a yacht. Very expensive. Trust me on that. Now, when do we write tests? 178 is flexible, but you need to be smart. Let's consider. This is a traditional test sequence. There's nothing wrong with this. This is what most of our clients use, and most of you in the audience, and wow, we've got a huge crowd dialing in here at 5 o'clock in the morning in the USA. But most of you probably do this. It's okay, but it's not great. You write requirements, review the requirements, design, review, code, review, write tests, execute tests, review. That's fine. That's the traditional waterfall. But let's consider something a little smarter. Can we do it like this? We write requirements, then we review the requirements by writing test cases, okay? We develop the design after we've written the test cases. So before we write any code, we actually have written those test cases and use those test cases to refine that. If we don't do this, the police come and get us. Hear that in the background? Exactly. So we timed that perfectly to show exactly what happens if we don't do it this way. You don't want the DO-178C police coming after you. Avoid those sirens, but instead do it this way. Remember, not this way, do it this way. The next gap. Bingo. Next gap, requirements-based tests, not just unit tests. Unit tests are great, we need them, but we don't do inspection and demonstration. 2 gaps there. Let's be more efficient about this, right? So remember, what is testing? Well, testing is a part of the verification pyramid. It's based on reviews. That's the foundation of the verification pyramid. Everything gets reviewed. Then tests. We only test 2 things. We test the requirements. Which ones? High level or low level? Yes, all of them. And we test the code. So 2 things. That's a little humor. There only are 2 things. You test all the requirements and you test all the code. Analysis is very small at the top. We don't do demonstration inspection. That's subjective. Instead, we transform those 2 gaps there into an analysis step that's only used when the combination of review and test is not conclusive. Okay? So, we engineers like equations. V equals R plus T plus A. Verification equals reviews plus tests and analysis. We often see a gap of missing reviews or proof of reviews. You need checklists to prove that everything was reviewed, level A and B independently. Plans, standards, requirements, high and low level. Design, code, tests, test results. Traceability, top to bottom. Have all the requirements been implemented successfully per the requirement standard? And bottom to top, level A, B, C. Only those requirements are implemented. No dead code. All deactivated code is justified. We have full structural coverage, statement coverage level C, decision condition coverage and statement level B, Modify condition decision coverage, statement coverage, level A. Very common gaps in there with missing those things. So print out that page and make sure we do that. Now tests, remember, does implementation meet specification? Test the requirements, the code, the logic. It looks like this. There's 4 categories of tests. At the top, we've got functional tests. That's all the requirements. We need high and low level. There's 2 gaps here. Oftentimes, people test only the low-level requirements because they have perfect decomposition, so by testing the low level, they automatically test the high level, right? Oh no, not necessarily. You need to consider both high and low, trace both high and low in a sequential fashion with transition criteria. Normal range testing should be accomplished solely by functional tests, but in case you haven't, then the other forms of testing are white box. Notice the font? Functional testing. I made that in black. It's black box. White box. There you have it. Normal range, robustness test. Try to break the code. That's the rainy day scenario. Finally, structural coverage analysis. For level A, B, and C, have you covered all the code? Common gaps is missing normal range test cases, missing high-level functional proof, missing range and robustness tests, performance and timing, and finally the structural coverage. So 2 gaps in there. Now number 7, modeling really is the future. As our aviation software becomes more and more complex exponentially, we need to step back, consider modeling, and that means DO-331. DO is a document. ED in Europe is European document. Nothing special, but DO-331 requires a modeling standard. The ideal situation is to have a specification model and also a design model, okay? So let's consider design model, spec model. It looks like this. We have high-level requirements, then the spec model. Spec model includes functional, performance, safety, interface, derived requirements, the additional aspects that are added by the engineers that need to be reviewed by safety. Then design model, low-level requirements, derived requirements. This is the architecture, the inner workings, internal data structures, internal data control flow, architecture. Both spec model and design model can be merged afterwards, just like low-level, high-level requirements can be merged in one document, but they must be reviewed sequentially. Spec model first, then design model, using separate. Did you catch that, folks? Separate standards for spec model, design model. 2 common gaps in there. Now, CMMI. You're probably wondering why you can't find great information on 178C online. Well, if you go to our website, you'll see a couple dozen white papers. Those are from my next book. You can go online and buy my older book, but that's a best-selling book on avionics. All the royalties go to the Boy Scouts of America, but you don't have to do that. Instead, do this. Leverage CMMI because there's great information in CMMI on how to do metrics, quality assurance, reviews, checklists. All these things are there, and there's a lot of similarity between CMMI and DO-178C. How so? Well, remember, CMMI, Carnegie Mellon University. This is very popular in the USA, not as popular outside the USA. So Carnegie Mellon wanted to devise a way to assess organizations, assess their maturity. It's the capability maturity model. They found that software is a creative art. Good organizations make better software. And there's 5 levels, okay? Level 1 is truly called the zone of chaos, basically professional hackers. Level 2, you have repeatable processes. Level 3, defined and consistent. Level 4, you include a feedback loop, metrics. You can predict and manage success. You can improve as you go. Level 5 is optimized, continuous improvement, with each level being a perfect superset of the other. Now, where you want to be, folks, is a little surprising. Level 3 truly is good enough. My companies in the past were level 4, but we didn't fully use level 4 because we don't want to improve our processes as we go. Instead, let's have independence, fully consistent, complete reviews, training, repeatable baselines, solid CM. Now, most avionics companies, this is amazing, folks, most avionics companies, and I've been to most of them in all the countries in the world, they are level 2. That is too weak, okay? It's too expensive. You can get certified at level 2, but it's expensive. You have to keep going back and repeating things and closing the gaps. Instead, just aim for level 3, read up on that, or you can download one of our papers at the Effusion website. We'll explain how to do that. We want your planes to be safe, so use CMMI. Now, here's the gaps. If you're level 1, you have to ask, why are you in this business? You have a huge gap. As you proceed and improve, your gaps decrease. If you're level 5, you still have gaps because level 5 is still missing salient points. But level 3, your gap should be 35 or 40% if you're a good level 3 company. Some people are level 3 and they have a 60% gap. What does that mean? They're not really level 3. Aim for level 3. Now, data control flow analysis. This is an interesting one. Almost always we find gaps in this area as well. So remember, software design, data control flow. Control flow, simply describe the control relationships between modules. Who calls what, when, where, how. What are the conditions under each module activation? It includes all the software modules, RTOS, kernel, DSP, drivers, graphics. It's really a call tree that's complete. Then data flow. It's a description of how data is manipulated within the design, how that source and destination data are aligned and defined for all the data, and it includes all data, okay? Common gaps, 2 there, insufficient control flow and data flow, okay? Now, deactivated code analysis. If we're a consumer device, deactivated and dead code is very common, but in aviation, level ABC, we can't have dead code, guilty until proven innocent. So we need to apply the deactivated code analysis and prove that all the code that's not called is there for a reason. What's the reason? A requirement, a low-level requirement typically. So different configurations, maintenance software. This is not conditional compilation, okay, but rather deactivated code analysis. We need to justify why any code is executed and why it's not executed. If you can execute it, it's not deactivated code. Deactivated code is code that should never be active during safety-related operations of that aircraft. Now, gap 11 was related to gap 1. Remember the ecosystem, okay? Or as we say in Europe, the ecosystem. It includes 178, 254, 4754, 278 for ground, DO-200 for data, 4761. All of these things are important, okay? And just to emphasize that ecosystem, let's look at deactivated code again. Dead code and deactivated code need the ecosystem. Remember? Remember that ecosystem? 61, 54. What is the configuration? Is it safe? Dead code needs to be removed, buried, get rid of it. Deactivated code looks like dead code, but it's not. It's deactivated code. It's sleeping and can wake up at a future time. Don't remove it, simply justify it and account for it. A very common gap. Remember, to design for deactivated code, we need a design mechanism that ensures that deactivated functions have no adverse impact on active functions or components. Let's provide evidence showing that deactivated code is truly disabled. This is another common gap, 2 gaps in here. We can't just justify, we have to show that it won't be activated. If there's a bad pointer error, and all of us have had bad pointer errors, let's be honest, can we ensure that it's not activated, okay? Finally, apply full DO-178. We do everything except the testing. If you can test it, guess what? It's not deactivated. Get it? That's the idea. Little humor there. So apply all of the objectives. Of course, you can't do testing, but you need requirements, documents, reviews, and tests that show it's truly deactivated and can't be executed. Okay. Now, number 12, a very interesting one. Many of us are increasingly using object-oriented technology. It's a great way to abstract, have portability, have reusability. One of our goals at Fusion is maximizing reusability and applying reusable software components that, because our systems are getting more expensive, more challenging, there's no reason to reinvent the wheel each time. So let's increase our use of object-oriented technology. Just one problem. It's vulnerable. There's 2 slides. Let's look at the common 7 vulnerabilities. First, inheritance. We need to minimize inheritance vulnerabilities. So let's enforce LSP, Liskov substitution principle. We all know what DNA is. We know that when we breed animals, we have purebreds and, as we say in America, mutts. That means a mixture, and I'm sure I'm a mutt myself. But with OOT, we need to enforce Liskov to prove we have good pedigree, good inheritance, and safe inheritance. We need to check for unused code, very common. The more object-oriented it is, the more reusable it is, the more unused, deactivated code. We have to justify that. We really want to try to avoid multiple inheritance. Now, let's take a look. Number 2, parametric polymorphism. We need to have some steps to minimize vulnerabilities. So we need to maintain data consistency. We need to ensure that the source binary traceability is there. Finally, we need to verify all the data types. Number 3, overloading. I love overloading. Imagine if all of my children had the same name. It would be very efficient, but a little confusing. Well, that's the challenge with overloading. We need to avoid that ambiguity. So, make sure we have coding rules to avoid ambiguity name collision. Use explicit, not implicit type conversions. Number 4, type conversions themselves. There's several gaps in here. We need to minimize those vulnerabilities by using explicit coding rules for how we do casting and conversions. We should not be able to tell who wrote the code. There's no ego here. I cannot tell John from Mary's code. Mary and John use similar coding templates. Let's define those in our coding standard and work that way. Next slide for vulnerabilities. Number 5, exception management. We really want to avoid unchecked exceptions, but don't propagate exceptions. If you don't know how to handle it at your local function level, ask yourself, how could a higher level function know what to do? Number 6, dynamic memory management. We used to avoid it completely. However, we like dynamic memory management. It's part of OO. So we need to employ object management and garbage collection. But make sure we avoid starvation and exhaustion. Several gaps in here. We always see this as a gap. Number 7, we increasingly like to use virtualization. Testing hardware is expensive, inefficient. So make sure we verify each virtualization layer. Think of it as IMA, Integrated Modular Avionics, DO-297. You verify each layer one at a time. Well, we need to make sure we have tracing through those virtualization layers. Physically, it's reviewed, it's documented, it's checked. So multiple gaps in there, folks. Very common. Now you don't have to make those mistakes. Now, let's consider. We've covered the 19 gaps in there. Let's summarize them. Let's consider a project that is CMMI level 3. It's a good organization, but it's their first 178C level B, design assurance level B project. Where are the gaps? This is the average that we've found from our 110 gaps that we've done over the decades. Number 1, PSAC, big gap. But It's easy. The PSAC's only 40 or 50 pages, and we have templates for all those documents. The quality assurance plan, it's a small gap, but look below at quality assurance itself. If we look at quality assurance, it's actually a larger gap because QA has more work to do. Now the CM is a small gap because CMI has good configuration management, but we have tighter configuration management. It applies to all software artifacts, suppliers, and the reviews start earlier. Once we review something, no changes without a problem report. The development plan has a very large gap, not because of coding, but because of requirements, decomposition, high to low level, data control flow, coupling, all those have to be in the plan. Verification plan, a huge gap. Robustness testing, structural coverage, how I verify data control flow, how I verify transition criteria. Safety assessment's a big gap. Remember our prior two on ARP 4761 and do that. You can download one of our white papers that teaches you how to do that if you want. Those are free. Requirements definition, small gap, just more detail needed for high to low level transitions. Design, code, functional testing. There's gaps in there. Just go back to the previous 30 pages of these slides and you'll close those gaps. Structural coverage tests, a big gap, but Ingo in 5 minutes is going to show you how to close those. Finally, CMQA, tool qualification, a large gap. And then, of course, we need professional checklists, reviews, and audits. Those are the key gaps, and that summarizes where they were. Now let's look at this test. You're almost done, folks. Everyone was false. 178C has minor changes. Testing is not used to improve software quality directly, but it does prove and improve what you really have by a feedback loop to improve the requirements. That's why testing is so valuable. Most bugs come from, no. Most bugs come from weak requirements. So focus on those two gaps that we summarized for you. Now, is DO-178C static? No. It's continually being interpreted via CAST papers, Certification Authority Software Team, by ACE advisory circulars, memos, certification memos in Europe. So it's continually changing. Work with your certification experts to close those. Coupling analysis is not performed only on code inspections, but also we need requirements. We need design and actual testing. It's that triumvirate. Demonstration inspection, we don't like those in 178. They're subjective. Instead, review, test, analysis. And good CMI rankings close the gaps. Well, it helps, but it doesn't close. You need to address those 19 gaps embedded on these prior 35 pages to really close them. So there you have it, folks. If you want a free paper on how to manage this and do it, just send us an email. And our next training on 178C and 254 is at Aviation Electronics Europe in Munich, June 19th to 20th. That's Europe's largest avionics event. Over 1,000 people will be there. I'll be there. Stop on by, say hello, and let us know how your gaps have gone. Let's close those so we all fly perfectly safe. Right now, I'd like to turn it over to Winnie and Ingo, who have a fun little surprise for us. Gentlemen?
Yes, thank you, Vance, for this great presentation. As you said, Ingo will give you now a short introduction into VectorCast, and he will show how VectorCast supposes tests of safety-critical software. Yes, I will now hand over to Ingo.
Yeah, thanks, Winnie. Thanks, Vance. No pressure on me, obviously, but I have to show a few things, just 5 minutes, while you can write questions and answers. So, as already mentioned, my name is Ingo Nickels. I'm field application engineer, and I'm a technical guy. I'm responsible for doing support for our product VectorCast. And VectorCast is in the avionics industry used for certification in safety critical projects for decades now. So the tool developed and has some features, some nice features, and I just want to show a very small part of it. We spoke about unit testing And so I will show how to create a unit test, let's say on a C file, so it's not object-oriented, it's pure standard C. We see our project, our testing project. This is VectorCast Manage that helps you to manage different variants if you want to test the same code with the same test cases in different variants on different targets, different compilers, different compile defines that activate or deactivate different code. There can be a large number of test environments here and a huge number of test cases, of course, so executing all of them or rebuilding all test environments would take a long time. That's why we have something to incrementally rebuild all test environments that need to be recreated or to rerun only those test cases that need to be rerun. And since we didn't change anything, we don't need to do anything. So let's start by creating a unit test environment. Let's say we want to start from scratch. We just need to tell the tool what is the name of our test environment. And then we pick one file that we want to test. If you wanted to do integration level testing, you can also pick more than one file, 2, 3, or 4, and test the functionality of a subcomponent of your application. In this case, we want to focus on unit testing. We just test a single file. Now, VectorCast automatically builds a framework around your C file that you want to test. We automatically create the test driver. We automatically create stubs and compile and link. And all you need to do now to test your software, to test the unit under test, is creating test cases on functions, for example, simple test cases to verify low-level requirements. So just by inserting a test case on a function, what we see here is the C file that we want to test and also functions that are implemented inside the C file. So right-clicking and inserting a test case allows us to specify values for global variables. Do you want to have some pre-initialization for global data? What are the values we want to challenge the function with, or how do we want to call the function? So usually in a first step of testing your low-level requirements, you would of course need your low-level requirements, maybe available in the tool. So we have a requirements gateway. You can import requirements from different tools, from different application lifecycle management tools or requirements management tools into VectorCast. It's implemented using a Python script, and once imported, you can look at the requirements and you can use the imported description of the requirements to specify useful input data and expected data. So in our case, let's look at some of the requirements. There is a requirement saying that when I place an order, then I have to update the check total. So when we hover over the imported requirement or the requirement that we just assigned to the test case, then we see how much different food is. So we can specify a specific order and say, for example, if we call, if we place an order using the entree chicken, then we would expect that the database is updated with a check total of 10 as specified in this requirement. And we could also check that the occupied status is set from false to true using or by specifying input values and expected values accordingly. So once we specified our functional test case, dependent on the requirements, we can execute test cases and see if the functionality is given. So this verifies that the low-level requirement is implemented in the code. It's a black box test. Then we come to the white box tests. As mentioned by Vance, we can look at the code itself. We can see what are sunny day test cases. For example, maybe we want to check the upper limit of seats, how many seats can be used to place an order. So when we duplicate a test case, we can look at defined symbol constants and maybe use the upper limit of a seed and see if the functionality is still given if we check a sunny day range, for example, the maximum number of seeds. And we can also test, of course, other limits like rainy day test scenarios. We can use values like maximum values or maximum +1 values depending on the underlying data type of the parameter. So in this case, unsigned short would be 65,000, and that's rainy day test cases, or we can test null pointers. And finally, structural coverage. We can also look at the code coverage and see, did we cover the lines as expected? Did we get proper code coverage, 100%? Do we have any dead code? Do we have any deactivated code? And of course, we can measure statement coverage, branch coverage, and MCDC coverage. Finally, if we instrument for measuring MCDC coverage and then rerun a test case, then you can also look at the MCDC analyze that we're doing. You can see that we analyze all the conditions in the code, and we provide a truth table showing you what would be the MCDC test cases that you would need to execute to get 100% MCDC coverage. That's it from my side. Back to you, Winnie.
Yes, thank you, Ingo, for your presentation. Very quick, like always. It's now time for the Q&A session. Please feel free to send us your questions you probably have. Please use the questions window. I think we have already some questions. Vance, can you answer some questions, please?
Yes, I see many questions. That's good. We have a huge number of people. So let's go ahead. Many of you have asked, is there a copy of this presentation? Well, we are going to make a recording of it. We have made a recording, Winnie and Ingo, and they will send you a link to the recording. As far as the actual physical file, we've got to check with our legal department on that. They don't like to here in the U.S. something about copyrights and whatnot. So we got to figure out how we can control that. But we'll do our best to answer that. Now, there was a question. I'll just use first names. Let's see, going in sequence. Brian asked, are checklists mandatory? Well, they're not formally required by 178. We just need the evidence and proof of reviews. So the key is, how do we prove we had a review without checklist? In truth, if we don't have a checklist and checklists for reviews and audits, it's almost impossible to prove that we followed the process, especially the transition criteria, okay? So while 178C doesn't mandate them or define them, the FAA doesn't, and EASA don't want to give you the checklist because then it seems that they're providing a minimum standard instead of a maximum standard. They want you to provide checklists. The objectives, the 71 in the back of 178, and the former job aids, SOIs, we have another question on that, those weren't checklists, okay? So the checklists cover your standards and your plans. They're not provided, but you really should provide them, okay? Now, another question from Ken. Deactivated code can't always be tested without destructive introduction of hardware faults. That's true. Now, the nice thing about 178, unlike the automotive or other transportation sectors, etc., we don't have to use destructive testing. If the only way to test something is by destroying hardware, you don't have to test it. That's where analysis comes in. So we can use analysis to say, look, I've analyzed this. Here's how I analyzed it. Here's a review independent of the analysis, and that's why it's justified. So excellent point. We don't have to do that destructive testing. Now, going on in order. Well, it looks, Bunang thought that I skipped number 11. That's a good point. I think I went back and incorporated it with the next one, so I think we did okay. Now, Akil asks, can there be dead code which can come in for requirement change? That's a good question. In fact, there cannot be dead code, but think about it differently. Is it actually deactivated code? Is there a reason for it to be there? Can I find it for level A, B, and C? Can I call it deactivated by proving it will never be activated, having a requirement for it to be there, reviewing that requirement, making sure it's part of the design review, reviewing it during the code review, and then showing by testing and lack of structural coverage testing that in fact it's not dead code, but it is deactivated code, so it should be covered in that sense. Okay, now, next question. Do we have examples of spec models? That was from Benoit. And we don't, but there are some in a white paper that are pretty good. You can download the MBD DO-331 white paper at the Effusion website, and that does have some examples from two of the more popular tools in our industry. And we work with all the tools, they're all good, but we can provide those in that white paper on model-based development DO-331. Next one, from Bahram. Do we need to plan for code reviews? Great question, and yes, we do. The code review needs to be part of the software development plan, SDP, that it's done, and then the details provided in the verification plan. When I say details, that's the high level. The actual criteria, the checklist, the coding standard would probably be referenced, not within the plan. And that's part of the standard, the coding standard. So for level D, D as in dog, you actually don't have to do a code review and don't have to plan for it. But you should informally. It makes a better product. Level A, B, and C, the white box levels, you really need to. So you want to include that. And what most of us use is MISRA, Motor Institute's Reliability Group. MISRA, C and C++ are the default go-to coding standards that most of us use. Now, Brian asked a good question. Do we see any changes for SOIs? Oh, goodness, that's a great one. Brian, you're an astute gentleman. So, SOIs were not part of DO-178B in early 90s. Then SOIs, stage of involvements, were added. The FAA wanted to make consistent approaches for how these were done. They published the job aids, okay? Those are actually on the website. They're checklists that weren't really checklists, just high-level process steps for the SOIs. Unfortunately, people justified the FAA's concern about putting those online and using those because people started using them as the maximum criteria, meaning if I do these things in the job aids, then I'm done, right? Well, that's the problem. No, they're not there anymore. So the new order, FAA 811049A, it actually removed that definition of SOI. So we're trying to get away from that by maximizing the breadth of the 1, 2, 3 reviews. So oversight is changing. The FAA is really busy, too busy. They're underfunded. EASA is busy. Everyone's busy. So in Europe, we're looking at the level of involvement activity that says, how can we reduce EASA's involvement by considering a company's pedigree, their CMI rankings, their history, the similarity of products, the criticality level. FAA is doing the same with overarching properties. What overarching properties can we apply to development such that if we've done this before, can we lessen the oversight? Okay, so the application of ODAs, self-approvals, overarching properties is really changing that environment. So great thing. Now, move on. That I think we have got all the questions. Oh, no, we got some, some more have come in. Oh, let's go back. Can we use design models to generate code? Oh, yes. So you must use a design model to generate code if you're doing autocode development. Several of the popular tools, I'll do that. You know, SCADE, Rhapsody, Magic Draw, Artisan Studio. They're all good. Now, only one of those is qualified SCADE. You don't need a qualified tool, but it helps. It gives you some advantages, and that's in the MBD paper if you want to download that. But you would use and must use the design model to generate code. So if you're going to generate code, you do need that design model. That design model has to meet the standard. Okay? Now, Pete asks, and that was Jerome that asked that before. Pete asks, are there any standards for languages such as Java? It's a great question. There are standards. Now, Ada, of course, is a standard itself. The definition of Ada has to pass the Ada validation suite, but Ada is not so popular anymore. The C and C++, there are standards. We've got the F-35, the Lockheed, standard. MISRA is the most popular, MISRA C and C++. But Java does have a safety critical standard. It's not as popular. Java's a wonderful language, especially for displays. There's a lot of OO capabilities. Portability, obviously, it's fantastic. But there's the vulnerabilities. Remember my 7 vulnerabilities that I discussed? Oh boy. Java really, let's say, is flexible and provides some great opportunity. That means we really need to tighten those vulnerabilities for Java. And just as we joke that we really don't use C++, we use C++, right? That's a safe subset of C++. We really use Java --. So use that safety critical version of Java. It's not FAA EASA recognized, but you can for level C and B, and of course D, no problem. Level A Java would be a challenge, so I wouldn't recommend that. Now, more questions have come in. Well, you keeping us busy? Here I am. Can we claim high-level testing using low-level tests? Great one. I tried to explain that. It's a common gap. Generally, you can, but not conclusively. The problem, Hiram, is that requires perfect decomposition. If we have mathematically perfect decomposition, meaning all high-level requirements are embodied in a full mathematically closed subset of low-level requirements, then implicitly, by testing low-level requirements, we've covered high-level. The problem is we don't have all the time, and we certainly can't prove such perfect decomposition, even during the LLR review. So instead, we need to consider the high-level requirements when writing those tests, and during the test review, we need to specifically use the trace matrix of high and low to those tests to prove, is there anything, any element within that high-level requirement that wasn't fully elucidated, specified in the low level, and if so, did we add test cases for it? So really good question. Now, next one, Shiva Kumar. What's the difference between verifying models and design models, like verification models and design models? Yeah, good question. All models have to be verified. A good thing to remember is anything the human does has to be assessed. If a tool does it, we're probably going to review it. And one of the upcoming questions, a new one says, what about tool qual? So we'll talk about that. Now, all models, spec model and design model, are done by humans, not the tool. So they have to be assessed according to the standard and a checklist. So when we do verification of the model, we are reviewing it and we're testing it. So we have to do both. The spec model is not tested, okay? We don't execute the spec model. Test is execution, dynamic. The design model is used to produce code. That one we can animate and use for formal verification. If we've got a qualified tool, then great, we get credit for that. So that's good. Now, another question. Folks, you're just hammering me with questions. You're keeping me awake here. Moshe, what about the trace matrix? How can cert authorities make sure it's complete? Oh, vital one. Good one, Moshe. So QA is going to assess transition criteria. If we go back to my green snake, remember the optimization route, every one of those boxes on the bottom half, the development testing cycle, has input criteria. Every one of those inputs includes the trace matrix. So the trace matrix must be proven to be used by the verification engineer. It's audited by QA. So Moshe, for you, aviation authorities and EASA, FAA, Transport Canada, China, you can see you're all logged into the webinar here. When I do training for you folks. I think I've been to most of your places. Remember, we talked about the trace matrix. You're going to do thread pulling. You're going to check 5 or 10 of those traces, and you're going to check the QA, or for hardware process assurance, of your supplier to make sure they specifically audited, okay, all of the transition criterias throughout the requirements, design, code, and test to prove that the traceability was used, that it was right, had top to bottom traceability. So it's going to be done 3 times, by the verification engineer, by QA, and then by your certification authority thread pulling. Okay. Next one, Paul. Does model need to be verified, and how does that reduce code verification? Great one, Paul. If we have a qualified code generator, such as FAPS or SCADE, good tools, then we don't need to verify the code. But most of you don't use a qualified code generator, maybe for expense or flexibility. You want UML, SysML maybe. Well, in that case, you do need to verify the code, and it's a little ugly, okay? Manual code review on code-generated code, but it will reduce the verification because you should find very few mistakes. You can also automate the standard compliance, the lint portion, by qualifying the lint portion. And that's usually the most tedious and probably the part of code reviews that humans are the worst with, is the standard compliance. The real focus of the code review should be, did this code accomplish the requirements according to the design, instead of how can I make it more elegant, or does it meet the coding standard? Does it have 4 spaces instead of 3? That's, you know, that's nice and pretty, but that's not really what we want to do. So it should reduce by using a code generator overall if you have a couple weeks experience of the engineers. So plan a couple weeks of training for those engineers and doing it a little inefficiency, but after they've done it a couple times, it's like changing the brakes in your car. It'll be a lot more efficient. Juno, is unit testing mandatory if we've covered it with functional tests? No, it's not. If you've got structural coverage, level ABC, robustness, then if you have good requirements, as you note in your functional tests, low-level requirements, and you have good testing, then your robustness tests, range tests, abnormal values, performance timing can be checked by functional. That's the best case. Make sure you use a coverage tool to do that, but indeed that's one of the larger changes of 178C over 178B is that ability to mandate that more detailed requirements are used in concert with structural coverage to prove that the code was actually covered by testing the requirements, not merely executing that code. Okay? And more questions. You're keeping them coming. Now, do reviews, Tomas, do reviews always need to be performed in a specific order? Requirements, test cases, etc. No, they don't. Okay? There just needs to be transition criteria. In fact, as we incorporate some elements of Agile, Spiral, some model-based development, we'll see that there's an iterative process where, in fact, we're not waterfall. No one really uses that waterfall. So we will need to perform those reviews with the transition criteria present for everyone, but not in a particular order. However, for example, let's say a low-level requirement review. I can't perform a low-level requirement review until all of the traced high-level requirements have been reviewed. So that means there has to be an order on the domain level. So the items I'm reviewing, the green snake inputs have to have been reviewed beforehand, okay? So there is an order, it's just not an overall order. It's the transition criteria order on the green snake that has to be explained. Okay, you're keeping me busy. Laura asked, can we explain the difference between normal range and robustness test with an example? Great one. So let's say I've got a voltage regulator. It is checking valid voltage of 24 to 28 volts. I've got a 32-bit implementation. So I've got millions of potential values. The equivalence class property says I test one of those values not on the boundary within range. So 24.5 or 27.69. That's my normal range, okay? if my data control flow does not change within that normal range, it's an equivalence class. That means it's a real normal range, and in that case, it wouldn't change. Now, for that 24 to 28 volt example, there are 4 robustness tests. There's 2 robustness tests right above 24, 1 bit above, and 1 bit below 28 volts. Those are robustness. I'm testing the boundaries, greater than, less than, greater than, equal. And then there's 2 additional robustness, 1 high, 1 low, out of bounds. So a total of 4 robustness tests and 1 normal range for a total of 5. Now, if I have good requirements, Laura, I should have tested those by functional testing. At DO-178 FAE said they don't care whether we call it normal or robustness. They functional test, but the key is, have I, with a white box examination, tested all 5 of those in that case? Okay. And we're rocking. I'll go get some more coffee. Karen asks, are the recommendations made by CAST updated in the tools, especially multi-core CAST32? Good one. So CAST32, that's a great paper, right? You can use multi-core as long as you disable all the cores except for 1. Well, that's what it says. CAST32 just came out, 16, 17 months ago, CAST32A, and it clarifies that if we have multi-core certified tools, for example, in RTOS, and there's several now from the big guys, then I will be able to have certified operating system and much less work to do for my multi-core usage. So it's a great question. Multi-core is increasing in predominance, and the tools are gradually catching up. It's probably 2 or 3 years later than we thought 3 years ago, but the tools are catching up. The key is to download CAST32A. So just download that from the FAA or EASA website. Okay. And let's see. Stenko asks, how to check if the IDE and compiler that we use is good enough? That's a good one. Ideally, we'd have qualified integrated development environments and compilers. However, that would be phenomenally expensive and would have to be requalified. So instead, we don't. The reason we don't qualify the compiler, there's 2 reasons. Number one, it's too expensive. But the official reason is because we fully verify the outputs of the IDE and compiler by the other objectives of verification, then we don't have to qualify IDEs or compilers. So is it good enough? Well, I would strongly recommend, unless your name is Thales, Honeywell, Boeing, Rockwell, General Electric, to use, those people have a lot more money, deeper pockets. I would recommend using what the big guys use and go with the popular vendors of avionics. So if you talk to the Vector folks, use their products, use their recommendations, you'll be in good shape. And that's the best thing that I would recommend that you do in that case. Javier, you're keeping it coming. Javier asks, if you develop software adhering strictly to processes, models, and coding standards, could you reach a stage where you don't need testing anymore? I love this question. Brilliant. So the answer is no. The goal is that eventually, when we reach that stage, our reviews and tests won't find any defects. That's the goal. So Javier, think of it as the radar detector, the speed camera in your country. Okay, I've got a few tickets. As soon as I know that you're not checking my speed anymore, I'm going to start speeding, okay? The only reason I don't speed all the time is because I know someone's testing my speed. So the testing should not find any speeders or violations of standards processes, but we need it to ensure that we're following it. So the goal, as you say, is to get to the point where we don't find defects in reviews or tests. And frankly, whenever we have defects in reviews or tests, we really have to ask ourselves, why didn't the originator review or verify his own work ahead of time? But no, testing's always going to be necessary. Folks, I'm doing an audit here in 1 hour in Los Angeles, so I'm going to have to leave in 1 minute. I've got time for one more question. Let's see. Moshe asks, how can we, certification authority, define what documents should be submitted for each type of certification, TC, type certificate, supplemental type certificate, experimental, etc. According to 178C. That's a good one. I would recommend going to 1309 and also the new version of 8110.49, and that's a pretty good list there. It's not complete because we still are expanding the ecosystem for safety and systems, and 178 kind of went backwards. We had 178 before we had hardware, 254. We had systems before we had safety, but that was after software, so we kind of did it backwards historically the last 25 years. So 178C is lacking that, so we have to step back and look at 4761A, so look at that. So especially for you, the cert authority, Moshe, you want to look at 4761A, the new version. Don't even know if you have that yet. It's not even formally released, but it mandates that the airframers, okay, the folks making UAVs, fixed wing, rotor, they do more of that safety assessment work at the integrated aircraft level. So that's a big difference, and that will define with A11049A and 1309 what the documentation suite is. Okay, folks, I apologize. I've got to hop in a car and hopefully avoid a speeding ticket and make it to an audit. So I'm going to bow out, gentlemen.
Thank you, Vance. Anyway, I would like to come to the end of this webinar too. I would like to thank Vance Heiderman and Ingo Nichols for their presentations. I thank to all attendees for the interest and the time you spent with us today. I hope you enjoyed the webinar and we can welcome you again at one of our next webinars. I wish you all a great day and a successful rest of the week.